So addition, you can do addition and subtraction, you can do division, do multiplication and all that. So multiplication, you can multiply, when you see example, we see examples anyway. So to on what to do. Um, so all the key operations: addition, subtraction, multiplication by a scalar, meaning that you can multiply by you can multiply maybe 5 times. Multiplication by scalar means can have a you
Recording
can
in
multiply
progress.
a 2 by 2 with 3 by 3. That will not work. So a multiplication. So please note. Determinant of square matrix. So estimation of determinant. In those that did further maths and do some advanced maths, you will apply this. So, but let me just add one or two information that could be important. So it's a single scalar value calculated from a square matrix. That's why it is n against n or m against m, because the number of rows is same thing as number of columns. So determinant is represented by these parallel lines. Then the matrix itself will be in the middle. This represents a scaling factor for a 2D or 3D volume. So a 2D, we speak about area, and 3D, we speak about volume because of the height in the factor. So it represents a scaling factor for area, 2D, and volume, 3D, when the matrix transforms in transform a shape. Meaning that by the time you do a matrix, that means you get a single value. You're going to get a single value. Now, if that matrix is equal to 0, by the time you do a matrix, there's a collapse. Meaning no unique solution exists. But by the time you calculate the matrix, the determinant of that matrix, and you have a value, a non-zero value, that means matrix preserves dimensionality. Then you can do the inverse of such a matrix. Calculation of a 2 by 2 matrix. Example of calculation of a 2 by 2 matrix is this. This is A equals to this matrix. The determinant of this matrix equals to A multiplied by D minus C multiplied by B, or B multiplied by C, anyone. So this is just a simple illustration. When it is 3 by 3, that is what I showed you the last time. That you cancel one line, now have, remember the last class, I showed you how to calculate 3 by 3. So further information regarding that statement, when the determinant is 0, that is, determinant is 0, what does that imply? Imagine you have a piece of paper to this space. A matrix with a determinant of 0 is like taking that paper and crushing it into a single line or a single dot. That is possible. Papers are generally two dimension because the thickness value is very negligible. So if you squeeze that paper or you narrow it down to just a one straight line, the determinant becomes zero. The collapse is a result of the fact that you have lost the dimension. Something that is two dimensions is now becoming a dot. You can't turn a line back into a sheet of paper because the information about the width is gone. More or less, or more so, because everything got squashed onto the same line. If you try to walk backward to find where a point started, there's an or there are infinite possibilities. In fact, none at all, because you have destroyed. It's just like it's just or more or less saying that you have a situation that is not reversible. So there are applications, there are things done on items that you cannot reverse back. So in that case, the expression you are if you now do such expression, you are going to get a zero in terms of its determinants. But now on the flip side, you have a non-zero determinant. This means that the matrix might rotate. You see, a matrix, it be 2D or 3D. That means the shape is not lost. But if a 2 by 2 rotates, flips, you still have the dimension intact or stretch, but remains a flat sheet. Then the dimension is still preserved. 2D stays 2D, nothing gets flattened into a pancake. In that case, you can do an inverse operation. Because the space wasn't crushed, you can undo the transformation. If you apply a force to anything and that thing did not crush, by the time you remove your force, it gains back its original position. It's like having a rewind button to get back to its original shape. I just thought, let me just do that analogy for clarification. Then how do you express inverse matrix? How do we evaluate inverse matrix? So for a square matrix A, you know what a square matrix is? The dimensions are the same. Its inverse, that is A to power 1, is the matrix such that when you multiply that inverse by the original matrix, you are going to get what we call an identity matrix. Where I is an identity matrix, 1 on diagonal, 0 elsewhere. For instance, when you multiply the inverse matrix by by the real matrix, I'm going to get 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is an example of that identity matrix. So, and this is for a 3 by 3 dimension, a 3 by 3 type of matrix. So the inverse exists only if the determinant is not equals to 0, like we discussed earlier. If the determinant equals 0, the matrix is singular, non-invertible. This implies that dividing by a number is like multiplying by its reciprocal. The inverse is the matrix reciprocal. Just like we know 1 over something is the reciprocal of it. For example, for a 2 by 2, the inverse can be equated to be 1 divided by the determinant times this. So I hope I have 1 or 2 examples to further explain inverse of a matrix. Yeah, I know I do. So we'll see that in a bit. Just give me like 1 minute. Let me. Uh, Okay. Um. Okay. Sorry for the short break. All right. So let's just move on. Where are we? Vast matrix. All right. Okay. I said okay. I think I said we'll have one example or two to explain this better later. All right. Um. So the matrix equation itself is a matrix equation fundamentally is of this form. Here are the coefficients of matrix, the vector of unknowns, what we want to solve for, then B vector of constants or observation or measurement. The compact form represents the entire system of linear equations. So you look at this expression, 2x plus y equals to 5, x minus 3y equals to 2. Represent this in form of matrix, this becomes this. That's a 2. You know, the coefficient of this y is 1. So the same thing applies to x, then minus 3. So then here we now have x and y, which are the um, what we are looking for, the unknown equals this value, which are the words the answers, the one on the right hand side, 5 and minus 2. So this is the A, the matrix itself multiplied by the vectors the unknown, then equals to B. So this is how to transform an equation to matrix form. So solving this expression, the inverse method, if determinant A is not equal to 0, the unique solution is this. So all you need to do, A, now just find the inverse of A, multiply it by B. We're going to get the answer for X. So verify A is square and determinant A is not equal to 0. That means, like I said, the square matrix is a matrix that has the same dimension. So first of all, it has to be a square matrix, not a rectangular one. It's just, this is just to explain what happened here. So calculate the inverse, then perform matrix application multiplied by. So why it matters? This is a direct algebraic solution. Note, computationally, other methods like Gaussian elimination are often preferred for large systems, but the inverse method is crucial conceptually. So most times when we do this, we do it as because we have small values of the system is a small one. The matrix number we can have 4 by 4, 5 by 5, 6 by 6. Those are advanced. In fact, that is let me say beyond the scope for now. So now to do more of that, there's what we call the Gaussian elimination method, which helps to solve that. So let's look at that. Especially when it is 3 by 3. Um, a systemic procedure for solving linear systems of equations. First of all, you convert the row into row echelon form by applying elements or elementary row operations. Once the matrix is triangular, the unknown are obtained through back substitution. Fundamentally, eliminate variables step by step until only simple equations remain. Very simple. Why use matrix? I think I've explained this already, so you can just go through this. Let me just say one thing. When we speak of Gaussian elimination, now we are focusing on Gaussian elimination now. Gaussian elimination, sorry. In the context of linear algebra, we are essentially talking about a disciplined way of peeling away the dependency in a system of linear equations until the structure lies bare. One begins with a couple set of questions, convert them into matrix form, that is AX equals to B, then uses elementary rule operations to drive that matrix into a upper triangle, or if one exists, a fully reduced form. Once the matrix has been tamed into the staircase pattern, the unknown fall out cleanly through back substitution. I think that was I explained. So let's see a system like this. You can see 3 by 3. So this becomes this. The matrix structures makes the elimination clean, consistent, and programmable. The core idea of the Gaussian elimination method, you swap two rows, multiply a row by a non-zero constant, add or subtract a multiple of one row from another. This operation simplifies the system without changing its solution. So let's see how that works. Go, create zeros below the pivot positions. For instance, look at this expression. You have created zeros here. This is what this means. You have to find a way of creating zeros. So one more elimination step. This zero now becomes, I can have this triangular form of zeros. So now the system is upper triangle ready for back substitution. You can see the triangle. Okay, this is the upper triangle. We're now ready for back substitution. Don't forget, this is X, Y, and Z. So this becomes 3Z equals to 9. From the back row, 3Z equals to 9, Z equals to 3. Then substitute again. Go to the next equation. This next equation, where we have Y or 1Y minus 1Z or minus Z, Y minus Z equals to minus 2. So Y minus Z equals to minus 2. When you now substitute Z here, you're going to get Y equals to 1. Then for the last one, this is X plus Y plus Z equals to 6. You can see. Then we have here our Z first, then we have our Y, so we can now substitute for X. So X will now become 2. Let me see. Oh, sorry. Okay. Now, geophysical problem, why geophysics cares? Okay, these are the different applications. So geophysical problems frequently reduced to linear system. Examples are, I give one example. These are more examples. So let me just go. Okay, so this is an example now of Gaussian elimination method. So let's go step by step. Look at this expression. By now, you know how this becomes the augmented matrix now. This is it. Okay, let me see if I can just write um, a step that was submitted. So this is 10. This is 5. and this is 13. So this is x. This is y. And this is z. Why these are 1, 2. This is 2 minus 1, 1. This is 1. This is what again? 3. And the last one is 2. You can see. So that's just the only step that's. So from these expressions, we have this. Then the augmented matrix now becomes this. You can see, just put this, then just put a line, then you now have this. This is what we now use to do our expression. Now, the first thing you do, look at this. We have 2 here, we have 3 here. We want to make this 3 is 0. I will advise do it one by one. Make 3 equals to 0. And so what will you do? What I have here is like okay, row 2. This is row 1, row 2, and row 3. So here, row 2, we now have a new row 2, such that this row 2 minus 2 times row 1. So in this point, we have actually what I used to do, what the easiest way is just, first of all, start from, make this 3 equals to 0 first. So that is, we are going to get a new row 3. So this is the new row 3, R3. And to get that new row 3, what you do is to row 3, this old row 3, you subtract 3 times row 1. Multiply row 1 by 3, then subtract it by, say, row 3 minus row 1. That row 1, you have to multiply it by 3. First, when we multiply row 1 by 3, this becomes 3, 6, 3, and if you multiply that by 30, okay? So when you now subtract, you now have 3 minus 3. This row 3 becomes 0. 6 minus 1. That is 5. Let me say, okay, row 3 minus 3 times row 1. Then we now have, this is, what did I multiply here? I multiplied 3. I think let me, typing is a bit slow for me. What do I do? What do I do to make it fast? Okay, maybe I should just do this. Okay, let me say, okay, let me do this. We have 1, 2, 1, then 10. So we have 2 minus 1. I want to do it, 3, 5, 3, 1, 2, 13. Good. I believe I just tried to I try to arrange this form, okay, so that I will have control over it in a faster way. So now what you do is multiply. First of all, let's start from, we want to make this 0. We want to make this 3 to become 0. So what I will do, first of all, write out this again, because just write out this again. If you don't follow this step, if you don't understand this thing, you might find it difficult to do. So please follow as I'm doing it. 1, 2, 1, 10. The next is still 2. 2 minus 1. If you make a mistake of writing the wrong value, that's the end. 5. Now, like I said, we are making this 3 0. So you can do anything, but let me see if I can. Let me just follow this. Now we have decided that our new third row will be, you multiply this first row by 3. You now subtract. You now say the third row minus the first row after you have multiplied the first row by 3. Now, what is the third row? This is the third row. It's 3. So first of all, one thing we should just do is um, make it easier. Let me. What I used to do, I want to write out the multiplication of this out first. So the new row 1 now becomes okay. Let me do it here. Let me just change the color. The new row 1 the new row 1 becomes so let's multiply row 1 by 3. That is 3, 6, right? 1, then 30. That is the new row 1. So now the new row 3 now becomes the new row 3 now becomes, let's subtract R3, this is row 3 minus, when we have multiplied row 3 by, row 1 by 3. So row 3, this is R3 minus when you have multiplied row 1 by 3. So this becomes 3 minus 3. So the row 3 now becomes 0. The next one is 1 minus 6. That is minus 5. The next one is 2 minus 1. So someone is raising his hand or something. Okay. Oh, all right. So I said 0, 3. That is row 3. Row 3 minus 3 times row 1. So this is the 3 times row 1 now. This is 3 times row 1. So that makes 3 minus 3, 0. 1 minus 6 minus 5. Then 2. Okay, sorry, there's a mistake here. This should I should have multiplied this by 3, right? Because this is still 1, so this should be 3. This should be 3. Will this thing work again now? This should be 3. Let me see if I can insert. Um, oh, it has disappeared. So let me write it again. So 1 times 3 is 3. What again? 6. That is 3 times 2, 6. 3, 30. So um, so this will be 2 minus 3. That is minus 1. Then the third one is 13 minus 30. You're going to get minus 17. You can see. So this is now the new, this is how this was obtained. You see. Now we have, this is for just this last value. You can see this second one is still showing this. So now let's now, what can we now do to this second row to make this becomes 0? So that means what you next thing you do, you just write out this first, write out this. So let's do that. Let me change the color again. Let me change it to this green. So we are not we don't have any problem with row 1 and row 3. We just want to make this row 2, this 2 to be 0. So this means let's write out 1, 2, 1, 10. Row 2, we don't have any problem with row 2. So let's go to row 3, 0. I mean, row 2 is what we are working on. So we don't have any problem with row 3. Let's go to row 3, minus 5, minus 1, minus 17. So now, let's now do something about row 2. So what can we do to row 2 to make this 2 become 0? So we have to, it's either we do this, because we cannot touch this again, because there's nothing we multiply with 0 that will give 0. So we have to go to row 1 again. You have to go to row 1 again. All right. So if you can do this method, is this one I have here is still going to give the same answer, but I want to do it one after the other. So let's go to row 1. If you multiply row 1 by 2, you're going to have 2 here. So when you subtract, you're going to have 0. So that's fine. So let's multiply row 1 by 2. So this will become 2, 4, 2, 20. 2, 4, 2, 20. Please don't forget 2, 4, 2, 20. So if this is 2, we can either do 2, this is row 1 minus row 2, or row 2 minus row 1, anyone, just be consistent. Okay, so let's do this row 1 minus row 2. So, and don't forget what you have multiplied. If I do that now, okay, let me do it. Or do it. This will not give me what I want. Okay, let me just do it. Let me just do this. So our new row 2, let me just put it side by side here. Our new row 2, oh, sorry, our new row 1. Okay, let me put it on top. We are multiplying it by 2. So we have 2, 4, 2, 20. So this is our new row 1. R1. So that's what we have to do, not this anymore. So now this becomes if you let's do 2 minus 2, that is 0. 4 minus 1. 4 minus 1. That is 5. 2 minus 3 minus 1. And the last one is 20 minus 10. That is 10. You're going to have this. So the next is now what we have to do to this to make minus 5. To make minus 5 is 0. And that is just, you just add. You add row 2 plus row 3. When you do that, for row 3, you are going to have a 0 here. So that means you still have this one untouched. You have this one untouched. Then for the last value now becomes 0 plus 0, we have 0. 5 plus minus 5, we have 0. Minus 2 plus minus 2, I'm sorry, minus 1 plus minus 1, we have minus 2. 10 plus minus 17, we have, that's minus 7. So that will be the final answer, the next answer. So hope I have not made any mistake the way I'm looking at it.
Sir, you've made a mistake.
Oh, okay, I'm looking at it as if there's a mistake somewhere.
You did 20 minus 2.
20 minus what?
Value. You did 20 minus 10 instead of 20 minus 5.
Okay, let me see. Oh, 20 minus. Where I'm looking at it too. Where did I make the mistake? This one.
Yes, sir.
That is it. Because we have so many words I'm looking at the same time. Okay, so I think I'm happy you got it because by the time I say I want to raise it, the whole line we clean up. So 20 minus 5, this becomes 15. This becomes 15. This becomes 15. So this becomes 15. By the time I say let me erase it now, it will not erase everything, just erase the whole line. So this becomes 15 too, right? This becomes 15. That then it tallies with this. Okay. It's just that the negative sign that is everything that one is the negative sign does not matter anyway. Because if I multiply by my negative again, everything the negative will cancel. It will invert or it will reverse or invert. Yeah, it will invert. So if thank God you saw that. Thank God you saw that. So that is that. What again do I say? So this becomes that's why by the time I erase it, the whole thing will go. So let me just clean up. So that is just the approach. I'm doing this just show you how you. I think I have other examples there. So this becomes that eventually you are going to get this. So you can see eventually you are going to have this. So you have gotten the triangle now. Okay. So the next thing is just to say equate. Okay, Okode Philip. Okay, yeah, I think you have said that now. All right. Thanks for the observation. So the next thing is to now see minus 2. You know, this is the z. This is x values, y values, z values. So this is because minus 2z equals to minus 2. That's how we have. So I think I've explained this before. So that's eventually we're going to have your values. So Okay, I have another example. So the same process applies. So mathematically speaking, that is how you resolve it. So now, geometrical example, using geometrical questions to explain those formulas. Um, I think you have the equation here. It's asking me with, let me see how many questions, because most times example one, okay, matrix. Uh, okay, so this is the question and this is the solution. So I don't want to just go through it. You can see the equation here. If you have values like this and there's none, know that this will become zero. Okay, this becomes zero. So these expressions from this seismic survey, you're able to derive these systems of equation. So I just try to relate it directly to geoscience examples or geophysics example. So this becomes this. Since this is V1, H1, V1, H, then there's no V2, I mean V2H2. So V2H2 becomes zero. So you have to arrange it very well so that you won't go and make your Y to be zero. Whereas it is the X that is zero. But in this case, X is we have value for X, which is the first value. The second value is the Y, which is zero. So that's why we have zero times H2 here. Then we'll write it in this format, like we did. Um, also, it's just to write it. It's just to show how to write it, it's not to evaluate any other thing. Okay. So this is another problem. I said there are examples for you to solve using that inverse matrix. To calculate the determinant of A, does A have an inverse? Why or why not? If A exists, find A inverse. So this is determinant. Yes, because it is not zero. That's why it exists. So, like I said, it has been solved already. Um, we have another question. Okay, it looks like the first example I gave, but this time you have to solve. This time you have to solve. The answers are there. The third example, I also gave you the solution. So I think this is what I have for you for as regards matrix. So um, any question or clarification? Thank God, Corey, also that you noticed that because I'm like, there's something wrong somewhere here. Oh, okay. So any clarification again? So please, like I do, I will send this document immediately to the two class reps, and you should please share with your colleagues. Take time and go through the examples. It will help
Sir,
indeed.
good morning, sir.
Good morning.
Sir, is it possible for you to recommend a textbook for us?
Ah, textbook, book. Okay. You need textbook for the course or because of this topic?
For the course, sir.
They can't be. I can, but because we have. See, I have not done that anyway. But the one I'm used to is engineering maths.
Okay, sir.
I'm not sure of the volume, but I know because right now, if you go, I have to go to the topics to know to now check some books.
Oh,
And now all books are probably you are referring to online books.
yes, sir. Like PDF.
I used to have one, but most times they go too much into details. But it's okay. Ah, um, okay. No, just remind me again. I will try. You can just send me a message on WhatsApp. I will
Okay,
try and
sir.
see if I can try and get one that's suitable for these topics. Okay.
Okay, sir. Thank you, sir.
All right. So, any other comments or questions? So, like I said, do not just think it is simple as ABC. Yes, it is. but there are steps you should follow. Just like I made a mistake. If it were for an exam purpose, you just notice that you are not getting it. And in matrix, you can know if you are wrong or right. You can check again. By the time you get your x, y, z, you now substitute those x, y, z into the equation. If you don't get the equation, the answer, if x plus y plus z equals to 5, and you substitute x and y and z, and it's not equal to 5, you know you are wrong. So just like I made that mistake. If you make your mistake in public, you know that you are, so you have to go back again. At least we eat into your time. So practice, practice, and practice. And not only for this topic, even the one we did previously. All right. Um ladies and